When you think of space, what comes to mind? A silent, empty void between planets and stars, right? But what if I told you that this so-called empty space is not so empty after all? In fact, it's teeming with activity, unseen, strange, and fundamental to our understanding of the universe. What is the quantum vacuum? In classical physics, a vacuum is defined as a space completely devoid of matter, no air, no particles, just emptiness. But quantum physics has a different take. In the world of quantum mechanics, even the most empty space is far from nothing. Welcome to the quantum vacuum, a seething, energetic arena where particles constantly appear and disappear. This is the vacuum of quantum field theory, where the fabric of reality is alive with activity. Virtual particles and quantum fluctuations. Within the quantum vacuum, we find what are known as virtual particles. These aren't particles in the traditional sense, they appear out of nowhere and vanish almost immediately. But their brief existence has real consequences. These virtual particles arise due to quantum fluctuations, tiny, unpredictable changes in energy that occur even in the emptiest regions of space. In simple terms, the vacuum is a constantly shifting field of energy, always fluctuating and producing these virtual particles. The Casimir effect. One of the most fascinating demonstrations of the quantum vacuum's reality is called the Casimir effect. When two metal plates are placed very close to each other in a vacuum, something surprising happens. Due to the quantum fluctuations around them, the plates experience a force pulling them together. This happens because fewer virtual particles can fit between the plates than outside of them, causing an imbalance that creates a tiny, yet measurable, force. This is solid proof that the quantum vacuum is far from empty. The energy of the quantum vacuum. Now here's where things get even more mind-bending. The quantum vacuum isn't just full of virtual particles, it's also thought to contain a staggering amount of energy. This is often called vacuum energy. Some scientists even speculate that this vacuum energy could explain why the universe is expanding at an accelerated rate. This is the idea behind dark energy, which makes up about 70% of the universe. Could the quantum vacuum be the key to understanding one of the biggest mysteries of modern cosmology? The vacuum's role in quantum fields. But the vacuum's role doesn't stop there. In quantum field theory, space is filled with invisible fields that stretch across the universe. These are the quantum fields. Particles, like electrons or photons, are essentially disturbances or excitations in these fields. So even though the vacuum seems empty, it's actually filled with the potential to create particles whenever energy interacts with these fields. In a way, the quantum vacuum is the backdrop for everything we know in the universe. Is the vacuum truly empty? So, is space really empty? According to quantum mechanics, the answer is a resounding no. The vacuum of space is a dynamic, energetic place, constantly fluctuating, filled with virtual particles, quantum fields, and perhaps even the key to understanding the universe's expansion. The quantum vacuum challenges our understanding of nothingness. What seems like an empty void is actually buzzing with activity at the quantum level, another reminder that the deeper we dive into physics, the stranger and more fascinating our universe becomes. Thank you for joining us on this journey into the heart of the quantum vacuum. If you enjoyed this video, don't forget to hit the like button, subscribe to Fact Fusion Network, and click the bell icon for more mind-expanding content on science, the universe, and beyond. Until next time, keep questioning what you think you know about the cosmos, because, in the world of quantum physics, reality is always more than meets the eye.